Morning, Zoom people. How are you doing today? That right there, that one. All right, officially it is start time, but it looks like we're missing like a bus, maybe, right? I feel like one of the, I know you guys, most of you guys drive, so you probably don't know anything about it, but they let everybody out at the high school late or something? This is like my busiest in-person class. There they are. Welcome, welcome. Traffic bad or something? Traffic crazy or something? Yeah. I figured because it's like half the class I didn't hear you. All right, Zoom people, people in class. We're gonna let everybody else kind of get settled in. We don't need you open anymore, or you, but we need you. All right, those of you guys that are home are pretty much kind of ready to go. So I'm gonna share the screen real quick. So today we're talking about Unit 2, doing linear regression. So if you have your notes ready to go ahead and get those ready. I'm gonna give everybody that's coming to class another minute or two. You'll need your calculators again today. And then we'll talk a little bit about all of the information as well from that point. All right, those of you guys in class, to try to sneak a favor for you. I went off and printed the outline for the notes if anybody would like them. I have enough for this class at least. The copy machine was trying not to let me do it, but I did the best I could. So raise your hand if you'd like one. I'll bring them around. They're not stapled yet, but we can do that here after we go through them. You don't have to have one, but if you'd like to have one. Can't promise this will be the case all the time, but I'll give it a try and see what happens. You know, it's not something you'll have to turn back into me or anything. Just happen to have enough paper. There you go. Got me comment for that. Since the stars won, that comes my OU logo. He's wearing his name and stuff. We'll color him. Anybody else? Okay, like I say, you don't have to have this. Those of you guys taking notes on your own, perfectly acceptable. In fact, it's good practice for college courses and stuff. So you guys are going to do that. after we get done with our notes, I also have copies of the homework worksheets as well, if you would like that. I'm not gonna pass that out right now because you don't need it yet, but once we get to that point, let me know. Okay, so let's get started with this craziness and we'll go from here. So we're starting our new unit. My goal is to have all of your guys' grades done by tomorrow. So I've got the 2 tests to still grade. I think I've gotten most of the quizzes for 0 period, working on 5th period as we speak, and then 6th period, just gonna have to wait till it's their turn because I go in order like that. So I should have all you guys fairly updated by the end of the day, Wednesday, because it is the end of the 6 weeks or second, third weeks, whatever you want to call it, on Friday. Eligibility for you guys for this class is not a factor because it's an AP class, but I still want to give you guys your updated grades in case there's anything you need to adjust or change before the progress reports are done on Friday evening. You can tell right now if you're missing something because Canvas is going to show you a little red rectangle in the spot where your grade would be with a line for it. So it just says missing or incomplete or whatever. So if that's the case, just get in there and get it done. If it's open, if it's not, and you need me to open it, then shoot me a message and I'll do it. I am also aware that a majority of you guys, or some of you guys, have emailed me stuff that may have not shown up in Canvas. So just be patient with me if I marked it as missing in Skype, get back to it and fix it in there because I know some of you guys turned in stuff through emails, and I got that whole stack of fun too as I go up and update grades. So that's my fun. I planned on doing a little bit last night, but as Connor can tell you, there was something a little bit more important that hasn't happened since the year 2000 last night. So I decided to enjoy history and enjoy my Stars actually win a series that take them to the Stanley Cup Finals. So I know I'm lazy and I'm a bad teacher, but such is life. So I will continue to update your grades. So if you have stuff missing, I haven't started taking off points and stuff or being late, just get it done. All right, everybody. And then Omni, remind me, and we'll show you the code for the Albert IO so we can get you hooked up on that. So you can still get credit for it. Just make sure you remind me for the code. So I'm going to extend that to you guys since I've been slacking. We can all slack together and be happy. What else? All the Unit 2 stuff is here on Canvas for you guys. So if you're looking, where'd my chat window go? Good job here, Zoom, messing up my stuff. This is Zoom stuff here. There we go. So all the Unit 2 stuff is on Canvas. I'm inside modules. Here's your new module. So for this week coming up, today we're going to start talking about linear regression. We're going to do the guessing game activity near the end of class. It's one of my favorite things to do. So when we get to this part, especially you people at home at Zoom where I can't pick on you, we're going to put our phones away and see how smart we are. Because if we start Googling everything, then it's no fun because everybody's going to get it right. So we're going to do a guessing game activity. And then for your guys' homework, we have uploaded the Chapter 6 textbook problems. By Thursday, I want to get you guys assigned to a digital textbook so you don't have to use our pictures, but we'll do that on Thursday. I intended to do it today, but again, such is life. And then on Thursday, we're going to do day 2, and then you guys will have the packet to start working on the homework problems and stuff, which I can pass out to you if you need a copy. So this week's just kind of about learning. If you have questions and stuff, you guys know where my tutoring and all that is at. The resources for those of you guys at home at Zoom, if you're looking for anything, are below the module. So there's your notes outline. Here's all the slides we're going to cover. Here's the homework packet, answer keys for that kind of stuff, textbook problems that I was talking about. Don't worry about the FRQs yet. We're still kind of doing stuff. And Jessica, this is for you. This is your section. So optional review practice, extra work, because Jessica likes to be above and beyond. I like it. There's some extra stuff there. Did that help last time, Jessica, doing all that extra stuff? All right, so Jessica's saying doing a little bit of extra, not just the minimum, helped her test go a little bit smoother. So things to consider. I know we're all busy, but if you do have a little bit of free time and you're bored and you're like, man, I don't know if I should, Snapchat or TikTok video again or whatever you guys call it, or should I do a little bit of studying? It's there if you want it. I'm not saying my stuff's more fun by any stretch of the imagination, but it is helpful. All right, so let's get started on the notes. As usual, if you guys have questions, stop me in the middle of whatever we're doing, and I'm happy to answer those questions. So, my computer, we can do it. Very good. We're going to be talking about scatter plots, correlation coefficient, and the least squares regression line today. I'll turn the lights down a little bit. Enough light. All right, so we are going to be looking at new called scatter plots. With our scatter plots, we're going to be looking at 2 sets of data now, not one like we were for Unit 1. So Unit 1 was all univariate stuff. I would tell Connor, here's, whatever, heights of, male students at the high school, or average price paid per textbook or whatever, and we would graph it, but it was one set of data. We didn't really care about how it related to other sets of data. We just cared about that one particular set of data. Now we're shifting gears and we're talking about two sets of data. So we're going to be comparing how they interact / relate to each other. What we need to be careful as we're going through the beginning part of this unit is not to assume that just because they relate really strongly together that they're causing each other to happen. That's a very easy trap to fall into, especially as we start to learn statistics the first time. I can speak from experience. You get all excited when you see a strong relationship between two things and you're like, yes, I solved the problem. Why didn't everybody else do this? It was so easy. And then you have to kind of take a step back and realize just because two things are strongly related doesn't mean one is causing the other to happen. So we're going to get to see a little bit of that as this unit goes on. So you probably heard the phrase correlation does not imply causation. So that'll be something that I'm going to harp on as we go through this unit. So it's okay to get excited. It's okay to see that you can start predicting stuff. That's what I want you guys to do. But it doesn't mean we can answer all the world's problems by plugging any numbers into the calculator. We're going to talk of things like the direction of the graph. So if I say something like this has a positive direction, does that make sense to us? That's something you guys have talked about before in other classes, possibly maybe. All right, so we're going to talk a little bit about direction. We're going to talk about if it's linear or not. So we need to kind of know what to look for in order to make a graph linear. And then we're going to talk about the strength of that relationship. Is it weak? Is it moderate? Is it strong? Is there any relationship? And there's ways that we can measure this stuff. So it's not going to be just a judgment call, you know, using our eyesight and our best guess. We're actually going to have, you know, formulas and equations and that kind of thing to help us with these questions as we try to make it as scientific as we can. All right, so we're going to practice making a scatter plot right off the bat so we know how to do this. This is already in your notes if you have them with you, but I just want to go over them real quick so you guys can kind of see. Whenever you're making a scatter plot by hand, we are doing what we call sketching the graph. So it's like you're sitting at the bar with your friends, drinking non-alcoholic beverages because you all are good children, wink, wink. And you pass a napkin over and you're discussing a relationship between two things. That's what I mean when I say sketch a graph, all right? So some of you students do really well with your graphs, like looking at your graphing projects. I'm blown away with the quality that you guys are able to do with your paper graphs, and they're awesome. I just don't want you to spend the amount of time it takes to do that on an AP exam or a test, because that takes away from your guys' time to answer questions. So those are all positive things that you're able to do. In fact, I'm jealous because my graphs always look terrible. But when it comes to what we're doing for tests and stuff, I want you guys to get into the habit of practicing how to just sketch it. Like, what is it I just need to put up there and be done with it, even though it's not perfect. So we're going to practice doing that. And then in the calculator, everything's going to be fairly familiar from our last unit. Our X values, so we're going to have two lists now instead of one. Our X values are going to go on our first list, and our Y values are going to go in the second list. Usually those are L1 and L2 in our calculators, but they can be different. This should be a familiar step. You hit the second button and Y equals to bring up your stat plots. Luckily, our graph is the first one that we're working on today, so we don't have to change anything. And then just want to make sure our lists are in there the right way. And then we all know this step, hit zoom and then number 9. So all this is going to be familiar. So without further delay, there's your data. Type it into your calculator. Be very careful about keeping order consistent. So if you do your X values from left to right, 16, 24, 42, etc., then your Y values also need to be in the exact same order so that your rows in your calculators are lined up. So 16 needs to go with 24. If 16 is not with 24, you're opening yourself up for crying and pain because you're going to be looking at different data. Very important on this one that you keep the order consistent. So I don't care if you want to mix it, but they better be mixed the same way. That makes sense. All right, so again, typing your lists into your calculator. X's should, you want to do this the consistent way, go into L1. Y's should go into L number 2. All right, the data is on your notes too, so I'm going to switch over to my camera view if you need it. Is camera still working? Yes, it is. All right. So you got your calculator. We're going to get to all this stuff in a second. So this is from last class. Go to stat, go to edit, and this is where your list should be. So 16, 24, 24, 30, etc. should be typed in like so. Then what you want to do is hit the blue button, or whatever color it is on yours, the second button, and then Y equals. It's going to bring you back to your stat plots. Again, we've been here before, so this should be kind of a review. Press number 1, and you're going to see all your graphs again. The very first one, as long as you're highlighted on, you'll be good to go. So switch that if you need to. The very first graph is the one we want. This is our stat plot. And then from here, just double check, are your X's values in L1 and are your Y values in L2? So Lsrl can have, 12, 13 lists if she wants, or whatever the calculator holds. That's perfectly fine. She would just need to make sure that whatever data she's trying to compare right now, that the X values that she wants are the right list and the Y values are the right list. So you might sometimes see me switch it just because I don't like to retype the same thing in, 15 times over as I teach every class. So I keep all my lists kind of in my calculator. Anytime you want to switch these, it's the second button and then whatever number on the calculator you want to switch it to. So if Lsrl's like, no, my X list is list 7, then she would hit second 7 and it would fix it. And then she's good to go. So you can change these as you need to, and then you can always change your dots and colors and all that kind of stuff if you got the ones in class and you want to be fancy. All right, once we have this set up, we know to hit graph. A lot of times what you guys see again is this if it's been reset. So hit the zoom button and then go down or press number 9 and ta-da, there's my graph. Everybody find that okay? And if I get too excited, just calm me down because this is kind of stuff I like. All right, so we got a graph here. So your goal is to sketch it. So when I say sketch, I'm talking like you're just having a conversation casually and you found a napkin and like a pen and you're just, hey man, I got this idea. Let me show you. That's what I mean by sketch. So start off by drawing just a simple XY axis setup here. Again, okay. So like I say, some of you guys do really well at your graphs and I appreciate it. Don't change that. But for the purposes of a test, simplify. If you're looking at your calculator, you can hit the trace button again and get some information about your dots without having to make a scale. So normally, when you guys were in like middle school, high school classes, you'd have to sit there and divide all the little points up equally and make a scale. We're not worried about that. So I'm going to hit the trace button and it's going to take me to my lowest point on the bottom left there. And on mine, it says X is 16, Y is 24. You guys got the same thing? So I'm going to draw right here a little mark for my X value and put 16. And I'm going to draw a little mark right here for my Y value and put 24. That's where I'm starting my numbers. And I don't have to start it at the origin. We just know that it's 0, 0. Awesome. Now I'm going to go all the way to the top here by hitting the right arrow a few times. And I'm going to see that my top one is X at 120 and Y at 60. Everybody see that on theirs? So then I'm going to go over here and put 120, 60. Again, we're sketching a graph. We're just trying to get the main gist of this. Put a little dot to represent your first one. Put a little dot to represent your highest one. And then here's where you guys who are artists can be creative a little bit. Fill in the rest of the dots using your eyeballs. Doesn't have to be perfect. You don't have to measure it with the ruler. Just kind of go like we got one kind of right here. I got one that's kind of like right here. Then it kind of curves up a couple dots this way. And then there's one more before that last one right there. Boom, sketched. 15, 20 seconds, so I had time for my questions. All right, we do still have the label. So if we go back to our data or look in our notes, it says that the X values are the ages of the children. And this is in months. So we want to make sure we label our units so that people know what we're looking at. And then for our Y axis, it says it is heights in inches. So I'm going to write over here heights and inches. And I can abbreviate. We need a title. So we're comparing the age of children to their height. So we're going to say age versus height in children or in kids or whatever. Just something so we know what we're talking about. And there's my graph. And it still took me longer than I'd want to take because I was explaining to you. But you guys now should kind of get the idea. Okay, so save yourselves that extra time for actual questions and stuff. And this will get you all the credit you need as far as what your graph's supposed to look like. All right, questions on that? Chat's looking good. Class, questions? All right, again, this doesn't have to be labeled every single dot, not necessary. All right, I know our box plot was, but we know that we could get, if we needed to, the data from our calculator and do all the independent dots if necessary. On the box plot, same thing, it was all there. So we're just trying to make sure we hit the highlights, because now we could kind of interpret this graph. We could kind of talk about its relationship status. We can talk about its strength or its direction and all that stuff just from this picture, and that's all we need to do. So this is more than adequate for your statistical sketching needs. All right, so set that graph in your notes because we're going to come back to it in just a few. Again, here's my super exciting Mona Lisa quality sketched graph in the notes. So very similar to what I just created on the notes there. So again, you don't need anything more than this. This is covering everything that you guys need. What we're going to do with this information, obviously, is, I don't know why it skips like that, is we're going to start talking about things like, again, what is the strength of the relationship here? So we're going to learn that it's strong. And there's going to be something that we're looking at in particular that tells us this. We're going to be able to identify that this is a positive relationship between these two things, meaning as one increases, so does the other. And of course, this looks pretty much a straight line, so this is linear. So we're going to talk more later, linear versus nonlinear. How do we know? Context is always important in statistics, so that's something you guys need to make sure you keep aware of. So that bottom sentence down here is how I would interpret or describe this graph. I would say there's a strong positive linear relationship between the age and height of children. The context is really important. So that's the blank right above your numbers on your notes and your data. When describing a relationship, blank is really important. Context. So you have to go back up a little bit to write that one in there. All right, we feel okay about this so far? Nothing too crazy? All right, so continuing onwards, I'm gonna give you guys a few minutes here, no, not too many, just to kind of think about what you think the direction or the association is going to be between these two sets of variables. So like for number one, do you think the heights of mothers and the heights of their adult daughters would have a positive relationship, a negative relationship or association, or doesn't really matter whatsoever? There is no association there. It's just your best guess right now. I'm just curious what you guys think. If you guys want to talk in class amongst each other or share ideas, you can. Zoom, if you guys want to put your thoughts in chat and kind of discuss with each other, again, feel free to do so. I'll give you guys like 2 minutes, just kind of discuss and see what you think, the kind of relationships you're going to have here between these two sets of data. And we'll go over. Take about 1 more minute. Again, just your best guess. Might be right, might be wrong, doesn't matter right now. You're just trying to decide. Use your already vast experience as a human. See what you think. So Connor, how late did you stay up last night, man, watching it? It took me a while to come down from the adrenaline rush. Being that I remember the last time it happened and it felt like forever. My poor son was super excited, but he had to go to bed right before the third started, so he missed all the good stuff. All right, so let's look at what you guys think. So heights of mothers, heights of their adult daughters. What do we think this relationship is going to be? Positive, they both increase at the same time. Negative, one decreases while one increases, or no relationship whatsoever. I see a couple of people giving singles and casts. What do you guys think? Some of you guys are saying positive. That's what we picked, because in general, you get your height from one of your parents. So it's likely that if your mom is tall, you should be tall. However, there are exceptions to the rule. Some people have very tall mothers and are short, and vice versa. Some people have very short moms and are tall. So that's not always the case, because genes don't act in a mathematical equation. So we would have what we call outliers. But in general, that's a positive relationship. I would also accept on that one no association, because you might say, hey, just because my parents tall doesn't mean I'm going to be tall. Perfect. All right, so as long as you're kind of thinking logically about what you're looking for, either one of those answers would be fine for me on that one. What about age of your car versus its current value? All right, we got some people saying negative. Anybody at Zoom? What do you guys think? All right, got some people saying the same thing on Zoom. Negative, that's what I agree with as well. Your car never actually appreciates or gains more value unless it's one of those weird classic cars. But for the most part, anytime you drive your car, it loses value. What about weight of a person and calories consumed? In general, what do we think? All right, some people are saying positive, very good. Again, this is general trends. There are exceptions, outliers, that kind of stuff. We'll talk more about those as we go. Height of a person and their birth month. All right, some people going, that has nothing to do with anything. Correct. Yeah, no association. Very good. So just because you're born in September doesn't mean you're taller than somebody born in like April. In fact, my brother and I are both the same height, and that's our birth month. Number of hours spent in safety training and the number of accidents that occur. Hopefully, we would expect what kind of training? Hopefully negative. Otherwise, we're wasting our time doing the training videos. Hopefully negative. Very good. All right, so you guys get an idea of kind of the questions or things we'll have you thinking about in this unit. If you didn't get those right, it's okay. Like I just was throwing it out there as a what if. All right, so Jessica, you ready? Memorize this formula and recite it back to me. No, I'm just kidding. So if we want to find our strength and direction of our data, we would use what we call the correlation coefficient, which comes with this very, 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 very complicated but fancy looking formula. Good news is the calculator does it too, so you don't have to actually do anything with this formula, but there it is, just so Connor can feel happy about himself that I'm teaching him math in class. So the formula says R, our correlation coefficient, is equal to 1 divided by the n minus 1, so that's our sample size average thing again where we account for errors, times the summation of our x values minus their average over their standard deviation, times the y values minus their average over the standard deviation of y. We will never, ever, ever use this formula, but it's in your notes and it's right there in front of you in case you want to look at it. Your calculator does all of this behind the scenes. It is glorious. It's happy times. We just type in a bunch of numbers onto the list, hit a few commands, and the R will show up. So what is the correlation coefficient? It's a number that's measuring the strength and direction of your relationship between your bivariate data. Okay, so we got our two sets of data. We got age and height of children. So what the R is going to do is tell us how strong it is and which direction it's going. Very, very helpful number to get familiar with. The official term is the Pearson's sample correlation. I will tell you I've never used in my lifetime any other correlation, so this is the most common and widely used version of the correlation coefficient. Others exist, and you might hear about them at some point if you guys take this stuff further, but just know that I've never used any other one but this one. It has two symbols, one for parameter and one for statistics. So if we're dealing with a parameter, we would use the little lowercase p here, rho, from the Greek alphabet. If we're talking about a statistic, we would use R. To be honest with you, this little R here is what we use pretty much like 95% or more of the time. I rarely, if ever, see the little p used. So just be comfortable with that. That R is talking about correlation coefficient. Notice we didn't even put the p up here in the title because it's so rare to actually use it. All right, but again, our calculator will give us all of this glorious information for us so you guys don't have to sit there and stress over the formula. The point of this class is to interpret the data and not struggle in finding the data. All right, so let's talk about strength. So when it's talking about the strength, because this is one of the things R is going to tell me, we're only going to see values of R between -1 and +1. That's it. So it's always going to be a decimal. You're very rarely going to see 1 itself, but nothing bigger than 1, nothing smaller than -1. Remember that, because we like to trick people into asking, you know, is it possible this is an R value? So between -1 and +1 will be your only values. If your R value is at or very, very close to 0, then what you have is no relationship between your data. They're just two random sets of data that exist in space and don't really care about each other. If your values are between 0 and 0.5, whether it be positive or negative, then you're now dealing with a weak relationship between your data. Something is there, not much, but something is there. Moving into the next category from 0.5 to 0.8 would be moderate data. Again, both either positive or negative. So the further you get from 0, the stronger your data is going to be. All the way up from 0.8 to 1, positive or negative, then you have something cooking. At least relationship-wise, again, we're not saying that X is causing Y to happen. We're just saying that they are strongly related to each other. So a little graphic to help your brain kind of see what's happening. Here in the middle, nothing's going on. Okay, so your graph on this one's going to look like somebody just dumped a bunch of dots all over the place. It's going to be all spread out everywhere. There's going to be no pattern whatsoever of anything. Get to the weak level. A small, somewhat recognizable pattern may exist, but it's still going to look very scattered of all your dots. The dots will then begin to tighten up and look a little bit more like a straight line in the moderate level. This is the moderate level was like the first picture on the notes. This one here at the very front of the page. So if you're looking at that, that was a moderate correlation. So now we're starting to see some sort of shape emerge from the data. And then the one we just looked at with that we sketched with the children, that was a strong correlation because those dots are pretty much in a straight line. So visually, this is what's happening in the background there. So that is our R. So that we're going to talk about here in a minute. How do you interpret that R? What kind of sentence and description do we write on it, et cetera, et cetera. But this is the numbers are going to tell you both the direction and the strength. So direction is determined by the symbol. If the number is negative, what do we think that means about our relationship? It's also going to be negative. So it's very nice. If you get like a negative 0.637 or something like that, then your data is going in a negative direction where it starts at the top left and goes to the bottom right. If you get a positive 0.84, whatever, then your data is in a positive direction where it starts bottom left and goes to top right. Okay, so the symbol of your R is telling you the direction. The number on your R is telling you the strength. So two things from one number, very helpful. We're going to show you where to find it in your calculator here shortly. That last part there, so the symbol on your R value there, Ami, is going to tell you what direction you're going in. So if it's a negative symbol in front of your R, like negative 0.8 or whatever like that, it's a strong relationship, but it's going in that negative direction from top left to bottom right. So it starts off really high, and as X increases, Y decreases, like our car value would. Whereas if it's a positive symbol in front of it, like positive 0.6 or something, then you have a moderate relationship that's starting low, but then as X increases, so does Y. So the direction of your graph, positive or negative, can be determined by the symbol in front of the R value. So it helps out. So you're learning two things. You're learning the direction and you're learning the strength. The only thing it won't tell us is if you have a linear or nonlinear relationship, but we'll cover that later. Because some nonlinear relationships will still come out with like 0.9 something, and you're like, wait, that's very strong. Doesn't mean it's necessarily linear, so we'll look at that later. Okay. Once we have our R figured out, the next step with our data would be to find what we call an equation that helps us predict answers, because that's the whole point of statistics. It's not just looking at what data already exists. It's taking that data and saying, okay, now can I start making logical assumptions of what's going to happen in the future? So that equation is called the least squares regression line, or Lsrl for short. You'll see it abbreviated quite a bit because it's a pain to write those all the time. It's Y with a little hat symbol, so Y hat equals A plus BX. Very, very, very familiar formula to algebra people. They write it as Y equals MX plus B. Okay, it's used very much the same way, although we care a little bit less about the y-intercept, and we'll talk about a y in just a second. Whereas in algebra, it's like everything is the y-intercept. Okay. So again, only use this with bivariate data. So Laura is not going to go back and take just our one set of averages of male students at the high school and start plugging this equation to it. It's not going to work. She's going to need two sets of data. It's the line that fits the best with the data. So I don't know how they still teach it in Algebra 1 when you guys were in middle school, but usually they would sit there and have you draw all the dots, and then they'd say, okay, take your ID or ruler, and you just draw like a little line between it. And teacher was happy, you were happy, you're like, yay. It's kind of the same thing, except we're going to do a little bit more official formula-wise. But that's all that is. It's the line that would go best between all of your data. It minimizes what we call the sum of squares. So that's all the differences between that line and all the points vertically. All right, on graphs that are very strong in the relationship, those sum of squares will be a lot less because they're very close to the line, whereas graphs with very weak relationships are going to have larger sum of squares, but it does its best to minimize it. We use our x values to help us predict, and that's in blue for a reason. Why? Our answers that we get from this formula by plugging in our x's are going to be just that, predictions. And no guarantee that anybody at that given x will necessarily fit that answer, but it's likely, especially the stronger your relationship is. But again, you've heard of things called outliers before, and especially when you're dealing with human characteristics or predictions, humans don't follow formulas, whether it be sports, medicine, whatever. There's no magic equation to figure out human behavior or characteristics. All right. A little bit more about your formula. Like I said, it's very similar to the y equals mx plus b setup. So we say y hat as the predicted y. So be careful, you will lose points if you just put y equals, because when you say y equals, you're saying that's the final answer. We've got to be official and say, no, we're just predicting. We could be wrong. The letter A now becomes your y-intercept instead of the letter B. So it still functions the same way, it's just a different letter. And B now becomes your slope instead of M. Otherwise, it's the same equation. When we're interpreting or defining our slope, as we will have to do in this unit, we're going to define y and x in words as we write out our equation. I'll show you guys examples of this when we get there. So always define your y and x in words. All right, so we've been doing lots of writing of definitions. Now we're going to get to play with the calculators again a little bit and kind of figure out where is my R value, what is my equation going to be for this height versus age of children. And we're going to start making some predictions off it and see what happens. So we're going to actually get to do some hands-on kind of experimentation with the one graph we've been talking about. So your data will stay the same, so you won't have to retype your data, which is nice. Okay. So again, be sure to put the hat on the Y. I don't want you guys losing points on stuff just because you've got the little symbol. So Y hat when you're making predictions. Finding your Lsrl and correlation coefficient in the calculator is going to be very friendly. So you're going to go and make sure, in a second, I'll show you where your stat diagnostics are turned on. If you have your own personal calculator, once you do this, as long as you don't reset it, you'll be fine. For those of you guys borrowing my ones in class, I would get in the habit of every time you get one of these, just double checking that this is set this way. Otherwise, you're going to be mad because you have to go back and turn it back on. We've already typed in for the second step there and to edit our X and Y values. So we're going to use the same ones again just to save time. But now we're going to go to stat calc and we're going to pick either number 4 or number 8. So I'll show you in a second which one I like. And then making sure our X and Y list are the same, and then we're going to calculate it. So let me switch over again to the camera mode here. So there's our graph. So we're going to figure out from this graph, what is our correlation, our R value? So we can answer the question. We already know it's positive, but we're going to answer the question, what's the strength, right? Is it weak, moderate, or strong? And we assume it's going to be strong from the picture. And then we're going to figure out what the equation is for these set of dots here so that we can start making predictions. So in your calculator, work your way back to the main screen. Click the little mode button here, and at the very bottom, about 4 up from the top, you're going to see this little phrase, stat diagnostics. If your calculator has been reset, it goes back to off. So you need to make sure you go over to on and press enter, Again, if this is your personal calculator, you're done. You never have to do this again unless you reset your calculator. But if you're using one in class, just double check this each time. And then whenever you're done in here, you can just hit second, quit, and you're back to your screen. All right, so everybody okay with that? All right, because if you don't have that set to on, then what I'm about to show you is going to be missing information, so you'll know right away. So go to stat. Normally we would hit edit and type in all of our data we already have. So we're going to, yes, Ami. Do you have a TI-83? Okay, hang on 1 second, I'll show you where it's at. So don't do anything I'm showing you and I'll come over and help you out. We've already typed in all of our data in edit. We have our X and Y values for the age in months and the height in inches. So we're going to go over one to Calc. And this is where you have choices. You can do number 4 or you can do number 8. Number 4 is what you guys used in algebra class if your teacher let you use the calculator. It still works, and if you're very comfortable with number 4, go with it. I prefer number 8 only because it's in the exact format as our equation, a plus bx. So it makes me happy to see things that match so I don't have to think about stuff. So press 8 or scroll down to 8 and press enter. And then it's going to ask you, what do you want for your X values? What do you want for your Y values? So again, picking on Lsrl, if she's got like, 15 lists over there because she's super sleuthing through all this data, she's going to want to make sure her X and Y values match up with the one she cares about. So in this case, you should have 1 and 2 if you're doing everything in class. Everything else right now, not important. We're going to show you how to use these things later. For just today, we're worried about getting to the calculate menu, and bottom, there's our information. So what do we see sitting here on our calculator? We see a couple things. Number 1, we see 2 R's, one that's squared and one that's regular. Both are important, but we're not talking about R squared yet today. We're looking at just the R. So on my notes, what I'm going to do is just kind of write down underneath here what my R value is so I don't have to go back and check it. So R is equal to, and like everything else we've been doing in class, 4 decimals makes Mr. G happy. So 0.9941. I haven't forgotten about you, Ami. I'll come over in just a second and show you. Now, based on our notes that we just took, what is this telling us about the strength of our data? Strong, right? Because it's between 0.8 and 1. So now I know I have a strong relationship. I already suspected it by looking at the picture, but now I know for sure, no question. Also, what do we notice about our R value? It's positive. So a positive R value tells us we have a positive relationship in our data. Look at my graph. Yes, this is a positive relationship, bottom left, increasing as we go across the X values. Okay, so just from R, if we didn't have the graph, we would know those 2 things. So you can put over here to the side if you want, just to remember that this is strong and positive. Now, we can also get our equation from the calculator for this set of data, and that comes from looking at our variables right here above, A and B. So the format you want to write your equation is, and this is where I like number 8 a little bit better because it's already in our format, is y equals A plus bx. So you're going to say y hat, because remember, you're making predictions, equals, all right, well, my A value is 20 and a lot of decimals. So again, 4 decimals is good enough. So 20 point, let's call it 4036 plus our B variable is 0.3421 when I round, 3421. And then at the end of that is X. So there's your equation. So now Connor can sit there and start making predictions of how tall children are going to be based on how old they are. So hit the second button. Second button, hit the little 0 button. So bring up a catalog order. So scroll down to see Diagnostics. Luckily, you'll never have to do it again. That's reset your calculator. So when you get to the letter D, there'll be 2 diagnostics. One for off and one for on. One more. Press enter on the on. Press enter again. And 2. So now just do your stat calc from your 2 lists like we just did, and you should show everything. Good. Anybody else got an 83 calculator? It's okay if you do. I'm not I have one too. All right, Zoom people, if you have a TI-83, message me or let me know, and I can show you how to get this on your screen too, so you don't have to buy a new calculator. It does work, it's just in a different spot. You get it to work on me? Okay, I just want to make sure we got it good. All right, so we got our data now. We've got our R value, our correlation coefficient. We've got our equation. So now we can start doing some fun things with it. Okay. Obviously, this goes a lot quicker when I'm not sitting here explaining things step by step. Anybody got any questions on any of the stuff I found? Not sure how to do it in the calculator before we move on. Zoom, we're okay? You guys are still so quiet, like, we're all still figuring each other out. Okay. And let's look at the rest of the notes then and continue onwards. All right, so what is that? What is your calculator doing when it is finding your equation? You don't have to write this down. This is just for your information because sometimes people like to know the whys and not just the whats. So when your calculator determines a best fit line, for example, like this, between these 3 points, what it is doing behind the scenes really fast because it's able to do so, it's finding the different distances vertically of how far the dots are from that line, and it's trying to minimize it to where it's pretty equal on both sides. Okay, it's not going to be perfect. It's never going to get it to 0, but it's going to get close. It's trying to minimize their differences so that it's equal both directions. So these dots here, it kind of goes, okay, 4.5 from this is about equivalent between -4 and -5 from that. All right, and then another set of data might look like this, and it's like, okay, we make another, so we move the point a little bit lower. So notice the line has come lower now to match it. And again, it's going to find the distance between the actual y value and what a predicted value would be. So it's like, okay, we got -3, +6, and another -3. So this is where we can kind of balance out the difference between the points. And again, it's never going to always, or it's not always going to get it to 0, but it's going to do the best it can. So in this case, the sum of these squares, which is all the differences of these, is only 54 versus the last one was 60 something. But it's trying to minimize that difference. It's like your average. When we have 10, 15 data points and we added them all up and divided by 2, and we started taking all the differences from the average when we did our variance. When we added them all up, we got back to 0. Why? Because it was, you know, -12 from this point, but it was 4 and 8 from that point, so that's +12. It balanced out. Same idea here. Again, you're never going to have to do this by hand, but some people are curious about what's going on behind the scenes. So what am I going to be writing as far as my interpretations or descriptions of my graphs, my slopes, and that kind of stuff? The stuff that is in blue is what gets replaced depending on the context of your problem. So for each increase in a, whatever your x is, of whatever unit it's being measured by, there is a predicted either increase or decrease, depending on the sign of your slope, in y. So these blue words will be replaced with the context of your problem. The word in green, very important if you want full credit on stuff when you're writing your interpretations. You have to say predicted increase or decrease. You don't use the word predicted, and what you're saying is, I know for sure this will be the answer, and somebody can come along later and be like, nope, I got an x value here, and this is really the y, and we'll talk about residuals and all that, and then you'd be wrong. So that's how you would interpret the slope. For the y-intercept, which we do not use very often, but it does come up on occasion, you would say when x is 0, so whatever your x values are, the predicted y is that number for whatever is at your letter A in your equation. So if you look at our number that we found in our equation, the 20.4036, that's our A from the height ones, right? So what our equation is saying is if your child is 0 months old, and basically fresh, don't have any age to them, then they start off at 20 inches on average. So in this case, our y-intercept is helpful. We're going to see, though, in some equations, our y-intercept is trash. Like, we'll never use it. Like, it gets like -4,363. All right, don't know what that number is. And it's just because the line goes back that far. That's it. So that's what I say. It's not used as often. The correlation coefficient, so this is my letter R. When I'm interpreting or writing a description about that, I would say there is a, and then talk about the direction, strength, and if it's linear or not, association between, and then my 2 variables. All right, so I'm going to show you guys an example of how these would look from our age versus height data here in just a second. All right, so these are our new descriptions for this unit. Not that we're never going to use SOCS again. We will later. But for this particular set of data, because we're talking about 2 sets of data, we're now interpreting different things and making different descriptions. So no, not really worried about SOCS stuff. Now we're worried about more interpretations. Looks like you guys are doing good. So let's go ahead and continue. So we have things that we call the explanatory and the response variable. So the explanatory variable is basically your x or your independent variable. It quote unquote causes the response variable to change. So it's the one that you're inputting into the equation. And then the response variable is typically your y. It's your dependent variable. It's the one the equation spits back out to you as a result. Explanatory and response variables imply that one leads to the other. Remember, we're not talking about like actual causation. We're just saying Based on this change, this is the result I would get. It is possible for X and Y to switch spots and be the dependent and independent, interchangingly. But it's rare that we would have the Y be the thing you're changing and the X be the thing that's responding. But it is possible. Okay, we're not limited to our equation only being used in one direction. So if in doubt, assume that your X variable is your explanatory and your Y variable is your response, and you should be good to go. Unless for some reason it just doesn't make a lot of logical sense, then you can flip it. So that's a case-by-case basis thing. All right, so once we got this written down, we are actually going to practice doing a whole problem. We've already done parts of it, so we're not going to start over. But we're going to revisit the ages and months and heights and inches of 7 children. We're going to walk through the whole process. Okay, you would type in your data, graph it, find your R, blah, 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 everything till the end. So we've already done some of this. We're just going to start piecing it all together. So you guys will have on the next page of your notes, or if you're writing things down, you will have what a final example of this type of stuff would look like. All right, anybody still writing this before we move on? Okay, so we have ages and months and heights in inches of 7 children given below. We've already typed these into the calculator, so you don't have to do it again. The first thing you would do with this type of problem is I would say, okay, go find the least squares regression line and the correlation coefficient, which we've already done. So you would go into your calculator, make sure your stat diagnostics are on, hit stat calc, number 4 or number 8. Again, I prefer 8, but it's your choice. And this is what you would write down as your final answer. You would say my y hat is equal to 20.4036 plus 0.3421x. So that is your Lsrl. And you're going to make sure you tell me what does your x and y stand for. So you would say, well, x is the age in months, Mr. G, and y is the height in inches. I need to know that. Because an equation with just x's and y's tells me nothing. You would then underneath that or nearby, if there's not space, write out that your R is equal to 0.9941. Now, we haven't had to interpret it yet. I just want you to write it down so I can see it. If you're following the format of what I kind of just described with explanatory and response variables, you're going to say that the age is your explanatory variable and height is your response variable. Meaning, depending on how old the child is, that's what I plug into my equation, and then it's going to spit out to me a predicted height. So that would be the response variable. Height increases as you get older and is dependent on age in this case, as far as this equation is concerned. Age is independent and can partially explain the height. The word partially can be added to make you feel better, because we're not saying that we've discovered the solution to how tall you're going to be is just how old you are. Obviously, that's not true. Questions so far? I want to make sure that you guys feel confident about your expectations as far as what do I have to regurgitate back to you, Mr. G, because I want to do good on my grades. And I get that. So I want to make sure I spend time because I felt like last time I rushed it. And that's my bad, 100%. Zoom, any questions? We okay with this? All right, looking good. Nobody's complaining yet. If they are, they're not brave enough to yell at me, so that's okay. All right, so some people writing here, go ahead and make sure you get everything down. That way you got some examples. Like I said, taking good notes is very, very highly suggested this year, just the way our situation is. And it doesn't look like it's changing anytime soon. So let's play by the new rules and make sure that we're doing well. All right, anybody still need the screen? Looks like most of us are good. Okay, so we would now then write our interpretation. So the next blank on your note says interpret the correlation coefficient and the slope in the context of the problem. So I need to know, kind of like you got to, describe to me what's happening here in your graph. What's the skinny, as they say. So for the correlation coefficient, you would say there is a strong positive linear association between age and height of children. So the strong positive part comes from the R value. It's a positive number, and it's between 0.8 and 0.1. The graph looks linear, so for right now, that's a perfect answer. We will know later for sure if it is not linear. It's not going to hide on you. It's going to be obvious. All right, so that takes care of the interpretation of the letter R. For the slope, you need to basically describe what's happening in your equation. So for each increase in, this is where your X value gets substituted in. So for this problem, age of 1 month, there is a predicted, there's that word, increase, because it's positive, of 0.3421 inches in heights of children. So basically what our equation is saying, for every month that, a child is getting older in our data, they're growing by an average of 0.3421 inches. Some obviously a little bit faster, some a little bit slower, but on average, that's what that slope is saying. So those are your interpretations. Those are your descriptions. This is what it needs to look like. So as far as what your final answers need to be for this, again, are there any questions, confusions, things you're not sure about? I'm happy to make sure you guys are good to go. Because I still feel bad about the confusion on the box plots and stuff. Like that was totally my fault. It caused a lot of undue stress, and I don't like doing it. All right, so again, the things in blue, these are what changes depending on the context of your problem. So you might have another problem that's weak negative linear relationship of whatever and whatever. And then you might say for the whatever you're talking about, there is a decrease of 4 inches, or I don't know, whatever you're measuring. So these will change depending on the problem you're looking at. All right, so I see a couple of people writing, so go ahead and get those examples put in, and then we're going to get to practice making predictions and see what's happening. And then we get to play the guessing game, see how smart you guys are. Hopefully you guys at Zoom, when we get to the guessing game, aren't cheating at home, Googling stuff on your computers, or same for you guys in class. Nobody likes playing trivia against Google. Yes, ma'am. Yes. Yes. Through practice, you can probably pick it up now. There's nothing specific. So basically, if it's positive, then you know your graph is positive and negative. And you got to see your graph with it. So if that makes sense. The thing that you're going to want to be comfortable by memorizing a little bit is the measurements for weak, moderate, and strong. But again, you guys get to use your notes on stuff, so it's not like I'm going to take all that. So just make sure it's somewhere you can find it. Right. So since our R value, if you wrote it down like 0.99 something, then we know it's very, like it's a strong relationship from that 0.99 because it was a positive number. We also know it's strong. All right, positive. We're going to see R values in a minute. Like your calculator will show you. Yeah. Even the 83s and stuff will do it. So it'll be obvious to you. Plus, like I said, you can always graph it and look at it. If the dots are going from, say, the top, whatever is left, down to the bottom right, then you know you can go like a negative. Yep, no, we'll have plenty of practice with all of them, Nami. Good question. All right, so she was asking if the R value helps with both strength and direction, and I said yes, just looking at the symbols will help out. So good question. All right, so let's practice doing some predictions. So here's our formula, very top of the screen. Y hat equals 20.4036 plus 0.3421x. In your notes, on your paper, computer, whatever you're using, predict the height of a child who's 4.5 years old, 20 years old. Let me know if both of the answers make sense to you or not. And then we'll talk about why it may or may not work for the 20-year-old person. I'm going to go grab a drink of water. So I will be right back in like 2 seconds while you guys are doing this. If you got questions, Zoom, chat it up. Let me mute myself so. All right, so those of you guys in class and Zoom, a very good question was asked, and I was hoping somebody was thinking about this. It says, predict the height of a child who's 4.5 years old. Do I just go ahead and plug 4.5 into the equation? Why not, Connor? You're shaking your head no. I like that answer. Why not? Yeah, our equation was built to be months to be inputted. So if you're putting in years as 4.5, what the equation is now thinking you mean 4.5 months. And so you're going to get a very short child at 4.5 years old. So make sure you convert that to months by multiplying by 12. So you should have inserted 54 in place of X instead of 4.5. So double check if that's what you did. It's okay. This is notes, it's practice. So it's not a big concern, but just things to watch for as you're putting these things in. So our answer comes out to be 38.877 inches. Remember, your answer is in inches when it comes back to you. So I converted it to feet just to kind of help you guys out a little bit. And I got 3 feet and pretty close to like 3 inches tall. So does that make sense? It's a little bit shorter than that, but does that make sense about the height of a kid who's 4.5? So somewhere like right there. Might be a little short, but it's reasonable, right? Like it's not the end of the world as far as the data. Now, when you plugged in the answer for 20 years old, what'd you get? Yeah, 8.5 feet tall, which is 8 feet 6 inches. Does that make sense? So what happened here? What do you guys think? How come this doesn't work for my 20-year-old? Perfect. That's the answer I was looking for. So you don't continue to grow at a consistent rate their whole life, right? So, you know, Mr. G's 36. If I plug in 36, all right, the answer is going to be scary how tall I should be, all right? You're adding almost another 16 years on top of that prediction. I'm not hitting my head on that ceiling up there. So I haven't continued to grow, at least vertically, maybe horizontally because I'm eating too much. But I haven't grown vertically in a while. Okay, so Connor's correct. The trend does not continue. So why not? What is the issue with this? Well, besides it being just the fact that you don't continue to grow, our data had a limitation to begin with, and we're going to go back and visit it in a second. But this example that we just did, this very last one here, predicting somebody's height at 20 years old, it's called extrapolation. And so you're kind of limited on what your data is allowed to be used for. So real quick, I'm going to switch over my camera just so you guys can see it. And then I'll put this back up here for those of you guys copying. If I look at my data, this is the data we had earlier when we were putting in our stuff. Okay, you can tell where the limits of your data are by looking at the minimum and maximum values of your X. So this is it's in order, so this is nice. This is my minimum value, and this is my maximum value. I can only make predictions using this data within that domain of X's. Or if you like the word range better, it's fine. I know calculus teachers panic when I say range for X's, but same idea. Okay, so between 16 and 120 months, that's it. My data is only good for that range of months. If I try to go too short, like I try to predict the height of a 5-month child, all right, it might work, but it's not really good for this data. If I try to predict anybody over 10 years old, because 120 months, I believe, is 10 years old, then this data doesn't work. So this data was gathered using only children this age, and so therefore, we're limited in our data here. If we wanted to predict the heights of older children, we'd have to include them, but then we might find that our relationship changes. Age and height are no longer going to be increasing at the same rate, like Connor said. So our graph is going to go, you know, straight, then it's going to hit a plateau, and then we're no longer going to have a linear set of data. So this is where statistics people have trouble going, well, how much do I use? How much do I predict, et cetera, et cetera. So please, please, please be careful. Do not extrapolate your data. This is where I hope that you guys become very cynical about how data is presented to you in your life, because a lot of people who aren't good at statistics will tell you, see, we got this trend, it's going to continue forever, trust us. And then it doesn't, and then they make you do things that you didn't want to do because, you know, et cetera, et cetera. I'm not talking about any example in particular. I'm just saying in general, be careful with the data you're looking at. All right, so extrapolation, very bad. Don't do it. Any questions? Good job, Connor. Appreciate you letting me pick on you. All right, so a little bit more about extrapolation, just so you guys are aware of the evils behind it. Again, you can only predict your values that are inside of your X domain range, whatever you want to call it. So anything outside of that, bad, don't do it. We don't know if the pattern observed in the scatter plot is going to continue outside this range, so do not do such a thing. This is where scientists and me have issues with certain topics. Because they swear up and down that trends will continue, and I say, there's no data proof so. Just what's done so far. Okay. Again, any questions on this stuff, guys? We okay with this? Again, the goal trying to make you guys smart mathematicians and statisticians so that whenever you go do research later in your life, if that's something you do, you don't have to worry about somebody calling you out on it because you're very sound in your math. All right, so could we use the equation to then estimate the age of a child who's 50 inches tall? What do you guys think? Can we reverse engineer this equation and go backwards? We would just plug in 50 for our y value and just solve for x, right? So since 50 inches is a relatively normal height, what is that? 4'2". Then there shouldn't be something too crazy. Method number 2, we can make our x list L2 and our y list L1 and then get a new equation if you want to go that way. So if you're going to be doing this a lot and you want to start taking people's heights and predicting their ages, then you would just flip it. You would then make the age, the height, the explanatory variable, and make that your new set of x's, and then make your ages the y's. And so the equation would work in reverse. So that's method number 2. But if you're just doing it once, the easiest method is just to plug in 50 for your y value and solve for x. So you get 86.5139 months approximately. Again, this is predicted. All of this is still predictions. And you get pretty close to the same answer on your new formula that you would create using reverse engineering, basically. And so if you guys are curious of what I'm talking about as far as the calculator, because some of you guys are like, oh, that's kind of cool. So what I would do, and I'll put this back up here in just a second. What I would do on my calculator is, okay, I got my L1 and L2, right? So when I did stat and I go to calc, what I would do is go to number 8, and I would just switch these two. So I would say, okay, this is now list 2, and this is now list 1. I'm just going to flip them. And then I would go, okay, do everything else, and it's going to give me a whole set of new data. Okay, so now I've got a new A variable, I've got a new B variable, and I've got a new R variable. So it's still a very positive, strong relationship. So as I start plugging, like if I take all your guys' heights, I can start guessing at what age you were. So I can reverse engineer. Then I can do it that way. All right, so it's easy to flip it. It's not too complicated if that's something you have to answer a lot of questions on. However, if you're just doing one question, sometimes it's easier just to use algebra. And like I say, just plug in, where's my stuff at? Plug in 50 somewhere in your equation. So you say now 50 equals 2, 4, like this. And then you just solve for that x at the end of the equation. So I would subtract and then divide, and I'll be all set. So either way you guys want to do it works. This way is good for like one or two. The other way is good for if you got like a bunch that you got to work through. All right, let's see what else we got. We're almost done. We get to play the guessing game. I'm excited. All right, so do you get the same age with both methods? No, but they're very close. Again, it's just the way the formula is set up. The R is different for the other way, so that changes the equation slightly. Which method should you use? The second method is more accurate. So that's the one, if possible, you should use. But like I said, if you're just doing it for one thing, there's no need to remake a whole equation for like one answer. All right, I believe that wraps up the notes taking part before we get to the guessing game. So any questions over any of this stuff before we get started with something a little bit more fun, hopefully. This was one of my students' favorite activities from last year. Although we're not working in groups this time, but I'm gonna let you guys talk to each other. Any questions on this before we wrap it up for today? All right, Zoom and everybody in the classroom. So Zoom people, you can technically go if you want. Like if you got something important to do, then we're done with the lesson. We're gonna do an in-class activity. But I would hope you guys would stay because this is a lot of fun. This is like the favorite thing that my students got, one of the favorite things I got to do last year. So what you want to do is put away your computers and your phones for a minute. We don't want anybody Googling the answers. You want to test your brains because some of the things I'm asking about happened before I was born and before you were born. So we're going to see how well you can make a guess. If you guys Google all the answers, then you're going to get a one-to-one linear relationship and it's no fun. So it's more fun to see how close you get. All right, where's my little activity? All right, so in your notes, it says making assumptions on what, when or what year things happen. So I'm gonna place them up kind of like at a time so you guys can follow along in your notes here at home. You're gonna be filling in the blank on the left and all of these, not the blank on the right yet. We'll talk about all those in a second. The blank on the left. So go through right now, 1 through 10. You can go further if you got your notes in front of you. But again, try not to use your computer and Google. It's not as fun if you do it this way. Make your best guess. When was the first cell phone call made? When's the last time the Cowboys won the Super Bowl? When the first Harry Potter book was published? The first African American was elected president. Michael Jordan won his first championship. Invention of the World Wide Web, et cetera, et cetera. Just take your best guess. This is a year. You're going to put a year in there. So like 1997, 2001, 1926, whatever you want to put in there, you're just going to put your best guess. Guys in class, if you want to, kind of discuss it amongst yourselves because you're like, I've heard of that before. Maybe somebody can give you an idea. No problem, Elliot. Have a good day, bud. All right, guys on Zoom, feel free to use chat and discuss amongst each other if you want to. We're going to create a linear regression off of your guys' guesses and see who got the closest possible. You don't have to pick the answer of your neighbor, but you guys can if you want to. For those of you that don't have the notes printed out, I'll leave the first 10 up here for a little bit, then I'll slide it up. I'm going to make sure the answers that I did find are actually the ones that match in here because one year we had Ishqs. Like I said, have fun with this, guys. It's okay if you're getting a wild guess in the middle of the dark and you have no clue what it is. Nobody's going to judge you. A lot of these things happened like right when I was younger, so. If you're using my screen here to make your predictions, let me know, either Zoom or people in class, if you slide it up so I can move it up. I know some of you guys are writing on your own paper. All right, we need me to slide it up a little bit. Okay. Tell me when there, Miss Jessica. What number are you on? You're on 11, perfect. All right, I'm gonna put it right there. So 10 is still up there, 9 and 10 if people need it. And you can go to 19, let me know when you're ready for, oh, actually 20 is the last one, so there you go. That should cover you. No? That's what math would be on your phone. Look at how much you guys best get. I mean, you can obviously look all these up, but it's not fun. Sorry, first time I did this, I'll go all over the place on a couple. There's a couple that I know for sure because I lived through them, but there was some that I had no clue about. All right, let's take about 2 more minutes making your predictions. Again, hopefully people at home aren't cheating on their phones. I can't peek at you, but it's more fun if you don't, trust me. Having a one-to-one relationship with your answers won't teach you nothing. We'll give you a few minutes there, Amon, to put in what you think, man. We'll give you a few minutes to think what answers you want to put in. No guess is a bad guess. I will tell you everything has occurred since 1900. So if you put 18 anything or earlier, then you're wrong. You can change that. So we're just writing down in our notes kind of what we think stuff happened. Connor, do you know the answer for number 2? I didn't know if you knew it or not. Very good. It's been sad how long it's been. All right, about one more minute. Zoom peeps, we'll go over the answers. Connor gave away number 2 in class, but it's okay. Only people listen. Look back at some of these gates and go like, oh, I was like 7 when that happened. All right, anybody need more time Zoom-wise? You guys good? Class, we okay? We good? Connor's ready. All right, so I'm gonna go over the real answers. You guys wanna shout out, come before I put them up here so we can hear your guesses, you can. If you don't, because you're shy or don't want anybody to know what your guess is, you don't have to. But if you think you got something, I wanna hear it. So the first cell phone call was made. What do you guys think? This is one I had to take a stab in the dark. It was way off when I guessed. Zoom, you can type into chat if you think you know the answer. Anybody want to take a guess? A little bit later than that. It's a good guess though. 97. All right, we got a 97. We got a 25. 37. 83. 72. 72 is the closest so far. 1973. Sorry, I got a coffee stain on there. Mr. Nick brought it in yesterday, dripped on it. 1973 for the first cell phone call. And it was probably a clunky one between like, 2 government employees or something. All right, what about Cowboys? Connor already said it in class, Zoom. What do you guys think? It's been a long, sad, lonely ride since this date. I remember it fondly because it was against a team I hated, the Steelers. It was Super Bowl 30. Guesses? Class, Zoom, besides Connor? I know he said it. 1996. I know, it's been a long time ending them. This is why I've switched to the Stars, and then they haven't won since 1999, so I haven't been choosing wisely, have I? 1996 for the Cowboys one. All right, what about the first Harry Potter book was published? What do we think? All right, we got a guess for 99. 97. Oh, 2007. You said 84? 85? It's all right, it's just a guess. 97, that's why I thought you said 97. 97 was correct. Very good, very good. Just a little old lady paying off her debts. Well, she wasn't old, but paying off her debts, wrote a book. Making millions now. See, all you guys got to do is have a good idea. Don't let everybody stop your creativity. All right, first African-American was elected president. They probably taught you guys this to death in social studies. What was the year? 2008, very good. All right, now we're going back into the depths of the archives. Michael Jordan won many championships, but what was his first one? What year? And now we're talking about NBA, not all those University of North Carolina ones. 85 or 86, okay. 91's a guess. Anybody else got a guess? Zoom? 91's very good, Connor. I bow to the prowess of your sports knowledge. So that's the one I was looking at going, oh, I was 7 when that happened, so I don't remember. It won quite a bit. And then I paid attention in the mid-90s when he did his return and had his final, yeah. And then he went to go play baseball in between there for a couple of years, which was kind of an interesting invention of the interwebs. 75, 91, 71, sorry, the maths are making it difficult. 71, any other guesses? All right, 90. Anybody of you guys ever heard of CompuServe? That's what the service provider used to be. You dial it in, here. As the 14.4K bit phone connection would try to give you just enough bit rate to download an email. And maybe a weather map if you had 15 minutes of free time. How things have changed. All right, Queen's first album. So Queen is a rock band. If you've seen the movie, you may know the answer. If you haven't, it's okay. I didn't know this one. Somebody said 70 something. 78, 79, 73. 73s. That's one of the older ones on here. First official Star Wars movie, episode number 4, A New Hope. Not all the new ones from the 2000s that nobody liked, and not the newest ones that are all on Disney Plus now. But the original, very first ever Star Wars movie, episode 4. What year do we think this came out? 80s is a very good guess. This one I actually knew because I had to watch it on VHS. I was not alive when this happened. Very close. It's in the 70s. Yes, exactly. That's where I learned about it too. Exactly right. When he's like, let's go see that Star Wars movie again. It's 77. Very good. That's hilarious. That's how I learned about it too. I was like, oh, that came out in the 70s, and I went and looked it up. All right, Miss Beyonce here was born. 76, good guess. She is older than me. Not that much older, but it is. Any other guesses? She's a 1981 child. The first iPhone came out. You guys have iPhones. We're in generation what now, like 15? Which one was the first one? Remember when this was like the thing? iPhones or Apple's always been like the first one to do something, and then they've gotten behind on their phones. Any guesses? It's in the 2000s. 2007, very good. You got it there, Miss Jessica. 2007, that's when we started getting into the smartphones. Before then, it was all those little, you watch old movies. I say old movies. The ones when you guys were born, like the early 2000s, they have the flips. Yeah. Or you watch the first couple episodes of The Office, first seasons, and Daryl's taking pictures of Michael's stupidity. He's using a flip phone. That's what you stand. We thought that was cool back then. Snapchat was created. I don't Snapchat, so I didn't have a clue. It's definitely very recent, though. 2013, all right, that's a good guess. 2011, very good. The first Percy Jackson book was published. So Ms. Nichols is a big book nerd. So that's where all these ideas come from. So I'm not into these books, but what do you guys think? Not that they're bad books. I just haven't read them. I saw the first movie. Yeah. Guesses? All right, you guys like me. You don't read a lot of books. 2005 for that one. All right, what about Drake's first actual album? Mr. Toronto himself. 2010, 2008, 2010. Very good there, Connor. Yeah, Connor's like, I representing there. I would not have a clue. I'm out of touch with reality, sir. All right, next up is Mean Girls came out, right? Is that the one we picked? Yeah. Not a show that I can say I partaked in, but it was on my TV at some point because my wife watched it. I just don't remember when. 2008. Very close. 2004. Good guess. All right, so you're writing your actual number on the right, but don't erase your estimated number on the left. We're going to use that later. All right, number 15. First Nintendo video game console came out in North America. How long it has been since the original NES Graystar presence. We used to have to solve the problems by blowing into it and wiping it with a paper towel. If you've ever owned one of those or ask a parent who ever owned one of those. What do you guys think? I'll give you a hint. It's in the 80s. 81. 80. Okay. Very close. 85. All right. The TV show Friends, very popular in the 90s. So what do we think? They watch that show anymore? I watch it a little bit. What'd you say? 93? Let's see how close you are. 94, very good. Excellent, Miss Jessica. So not bad. The first Hunger Games book was published. So not the movies, but the very first book. What do you guys think? 96. Not too bad. 2008. So we're in the right area there. All right. What about Toy Story, the first original movie? You guys probably grew up watching Toy Story. It's older than you think. What'd you put? 06? 03? 01? 01's the closest so far. 95. So short story on that. My brother and I, what was I? Just turned either 10 or 11 this year. That year, 11. First time I got to stay home by myself and my parents left and kind of babysit my younger brother. We made the mistake of watching the TV show X-Files. Have you ever watched that? Scared the crap out of us because now everything was moving, so we had to watch Toy Story. That's how I know it's old, because we were little. All right, sorry, just a weird aside. Full House, not Fuller House, the new edition, but the original Full House. What do you think, Amon? Do you know what Full House is? It's old, man. It's like even before my time. Jessica. 87. 87. It's old, an oldie, man. Back when, what's his face? Mr. Stamos was actually young. He's still doing shows now, but he's older. All right, last one, Law and Order. This show's been on for stinking ever. I think they're in like their 55th year, not that, but they've had a lot of seasons. What do you guys think? 82. That's not a bad guess. Not a bad guess. It's older than you think. 1990. Good job, Laura. A lot of people on that one are like 97, 98. I'm like, no, that show was on when I was like 6. All right, so there's all your years. So what you should have is, and we're going to stop here for today, you should have a list of your original estimates and a list of your actual answers. Save this list for a warm-up on Thursday. We're going to fill in the rest of them. If you want to do it on your own, you can. You don't have to. But we're going to go through the rest of this on Thursday. Make sure you remember how to do everything. That covers our notes. Zoom people, thanks for playing along. If you played along, hopefully you guys had a little bit of fun. You guys can start doing the bookwork chapter 6 stuff if you want to. I'm not saying you have to do next class or anything. All of our textbook stuff is always for test review. So the earlier you start it, the easier it is. But if you need to take a couple days to get things figured out, organized, you're still making up work, whatever, then obviously do that first. Thank you, Zoom. We'll see you guys on Thursday. All right, in class people, anybody want a hand printed out copy of your worksheets for this unit? I have them. All right. And I'm gonna come around with the stapler in just a second, so if you want things stapled, you know, we'll gladly staple for you. Prevent the spread of whatever we're dealing with. I'll be the only one touching the stapler just for them. Anybody else? Good. Good. Copies of the homework papers as well. You're still going to scan these and submit your Canvas. Like, you're not going to turn in paper to me. But if you don't want to go home and print them off, you want to keep them in your binder, there you go. You bet. Your parents pay. You want to do taxes, we support the bit. Yep. You need one? Ma'am. Yes, good job. All right, anybody else? All right, you can still do this digitally, but you can still write on stuff and submit it digitally because it's still going to be submitted to Canvas. When you guys are submitting these, most of you have been doing pretty good. Keep them to formats that load on my screen. Yeah, homework. Yeah, so I give you notes and all. Yep. So it has our schedule on here, which is nice. So you guys can kind of see our schedule. So our test over this unit will be on Thursday, October 1st. Middle of the time. You guys can see the outline. So normally I'd always pass those out to everybody, but such as life. All right, I got my stapler. You're going to need to staple, let me know. I'm happy to staple it. And then if you want hole punching, you can do that yourself. All right, get 2 stacks ready down. Oh, man. Boom. You got anybody else? I got a hole punch in the back too if you guys want. All right. Cool. Thanks for playing along, guys. I know that sometimes it's cheesy stuff, but anything to break up just writing notes and talking about things. Say last year we got to work into groups and I gave out candy to the groups that were the closest. So. Can't do that this year. Oh, I need to use the code thing. I forgot. Yeah. For sure. For sure. Just like we did last time. We can go over all that stuff. Yeah.
So I can just like fill in like when.
Yeah. Just fill in. The sheet has changed a little bit because we're going to be adding the other teachers in there too. But you can still get me at the same time. It's just they're going to see different options now instead of being able just to say I want this time. It's going to have me like from 2 to 3, and it's going to have a different teacher from different times. Just click on me because the other teachers liked what I was doing, and then so they wanted to borrow my idea. And so we're going to have like you can go to different teachers if you want to. I'm not saying that you have to, but you can.
Yeah.
All right, let me. Yeah, you can come in person or you can do Zoom. Either way is fine with me. I'm very flexible as long as they're not yelling at you next time. During fourth period. Just don't show up before like 1:45.
Yeah.
So like anytime after that should be fine. Because they usually have my Wednesday. Like I got 3 meetings a week, so that's perfect. Hang on, let me figure out where I can put you into this thing. I just want the class thing. Settings, maybe? There it is. So there's your code right there. There, hang on. There you go. Thank you, man. You can just leave them on the desk. You don't have to bring them. Yeah, your calculators, you guys just leave on the desk, and I give them the little. Yeah, and Ami, the the Albert IO stuff is just participation. So once it's all the way complete, whether they're right or not, I put in your grade.
Ladies and gentlemen, please stand and pause as we begin the Pledge of Allegiance.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation,